In our number system, we're in a 110 machine, meaning if I'm looking at place value, 1, 10, 100, 1,000. I want to convert this into an algebra machine. And algebra uses this variable x because I don't want to be in a 10 machine or a 3 machine or a 2 machine. So we're going to move from a 110 machine, something I know a little bit more about, into an algebra machine. Let's go back and look at our 10 machine for just a minute here. These were our singles. These were our tens. And to move to the next box, if you remember, we were taking groups of 10. So to get into the box immediately to the left, I need 10 groups of 10. And so that's 100, or we can write that as 10 squared. 10 squared means 10 groups of 10, or 10 times 10. So following a pattern, 1, 2, this must be a power or an exponent of 3. So when I'm in an algebra machine, because I don't know the size of my groups, like groups of 2 in a 2 machine, groups of 3 in a 3 machine, my group is unknown, so we're going to call that x. And so following the pattern, this is going to be x squared, and this will be x cubed. So there's a relationship here, and we're going to use this relationship when we convert to algebra. So let's go and figure out, how do we add algebraically? We learned to add left to right just recently. We went from adding right to left, and we're saying, you know what, we're going to add left to right, and there's a reason for this. If I add left to right, we added our hundreds. 30 plus 20 is 50. We added our tens, and then we added our ones. Then we looked at this number in decomposition into its parts, which would be 200 plus 30 plus 4. And underneath it, we're going to add 100 plus 20 plus 3. That was looking at it decomposed. Well, what we're going to do is we're going to bridge to algebra. If I go up here again and look, every 100 is an x squared. So if I'm in my base 10, I have 100. But if I want to go to algebra, I'm going to write that as x squared. So x squared is going to be equal to 100, and x is going to be equal to 10. And we can see that again from our little table here, that x is equal to 10. So to convert from algebra out of our 10 groups into an unknown size group, we're going to look at 200. So if x squared is 100, I have 2 x squareds, or 200. X is 10, so I'm going to have 3 tens and a 4. So 100 would be 1x squared. 20 would be 2 tens, or 2x, plus 3. Now here comes our adding left to right. We start on our left when we add in algebra, and we're going to add 2x squared plus 1x squared is 3x squared. Don't forget your square. 3x plus 2x is 5x, which would be 50, or 5x. And 4 plus 3 is 7. So my answer is 3x squared plus 5x plus 7. How does that correspond to our base 10? Well, if I'm adding 200 plus 100, I get 300, i.e. 3x squared. When I add 30 plus 20, I get 50, 5x, and 4 plus 3 is 7. So it corresponds directly. Let's try that again. I'm going to look at this number in its parts, called decomposition. 500 plus 10 plus 4 is 514. 200 plus 30 plus 1 is 231. Adding its parts, 700. 10 and 30 is 40. 4 and 1 is 5. Changing this into algebra, let's bridge from what we know into algebra. Recall, x squared is 100. So if I have 500, I must have 5x squared. X is 10. I have a 10, so I have 1x. And we can put a 1 there, plus 4. In the second row, 200 is 2x squared, 3 tens, and a 1. Adding left to right, 500 and 200, or 5x squared and 2x squared is 7x squared. 1x and 3x is 4x. 4 plus 1 is 5. So those numbers correspond directly. My answer would be 745 if I was using a base 10 or in my 10 machine. In algebra, this is my answer. I can't add hundreds to tens to 1, so we leave it written out in its parts. Again, notice I added left to right. Let's try that one more time. 600 plus 50 plus 8 in algebra would be 6x squared plus 5x plus 8. Converting my next number into its parts, decomposition, 200 plus 70 plus 3 would be 2x squared plus 7x plus 3. X squared is always going to be 100. Adding, I get 8x squared. 5x plus 7x is 12x. 8 plus 3 is 11. You are complete at this point in algebra. If I was adding its parts, I would get 800 plus 120 plus 11. Do you see the correspondence? 12 tens is 120. Now the problem is with our essential math skills, when you learn to add, we had to do this thing called carrying and borrowing. In other words, we knew that there was 120 and 8 and 3 made 11. So we put the 10 over, so we will get 931. If I add, this is 931. But here you are done. The best thing about algebra is you don't have to do carrying and borrowing. We like 12x. You do not need to carry and borrow in algebra. That makes it so much simpler than adding, especially if you were to go back and use the shortcut on this. By shortcut, I mean when you worked from right to left, you said 8 plus 3 is 11, and you would put the 1 and carry the 10. You don't have to do that anymore. We don't like that because that's not what algebra ends up being. So carrying and borrowing is no longer used in algebra.